Hi class, we're going to continue with our discussion on derivative. So as we talked about in class, derivative is the slope of the tangent line at any given point of the function. So let's say we have, so you see this curve on the right, let's say we have 2 points that's somewhere on this curve. So we're going to call this those 2 points. And the first point on the left, we're going to say that this x value is a. And so it's going to have a y value, and we're going to call this f of a because y is a function of a. And I'm going to change this y of x to f of x so it's just a little bit more clear that it is a function. The second point that's on the right, we're going to say that it has x value of b, and so its y value is f of b. Okay, and if we want to figure out the average rate of change means how fast is y changing over how fast is x changing. So change of y over change in x, like what we talked about in class with velocity, is basically talking about the slope of the function, right? So that is y2 minus y1 over x2 minus x1. So we're really talking about the slope. So the slope of what though? The slope of a line that's created by these 2 points. So if I draw a straight line through these 2 points, I can find the slope of that line, which is going to be my average rate of change. Now, if kind of remember from geometry, if you have a line that cuts through the curve at 2 points, this is called the secant line. So we're really looking for the slope of the secant line through 2 points. And those 2 points are a comma f of a and b comma f of b. Okay, and then just to write it in function notation, y2 is really just f of b, and then y1 is f of a, and same thing, x2 is going to be b, and then x1 is a. So that is the average rate of change. Now, if we're going to talk about the derivative at a point, we kind of talked about that in class, that it's not possible for a point to have a rate of change because there is no interval to change from. And so if we force it to have an interval as is, we're going to have a 0 in the denominator, which is going to be undefined. So we are forced to be clever, and to do that, we have to create a small interval. So let's say that I have this point x somewhere on the graph, and obviously it will correspond to a point that's on the graph. And we're going to say that y point is going to be f of x. And so what we're going to do is, if we want to figure out the derivative at a, this little prime is this dash or apostrophe on f. That means derivative. Okay, so if we want to figure out the derivative at a, we cannot do that. So we need to actually have a and then a point that is close to a. So we're going to use the point x. So using the average rate of change, we are going to take the point f of x, which is the y, minus f of a, and we're going to divide by x minus a. So same idea as before, except this time we're trying to get to a. So we're going to take the limit as x goes to a, meaning x is trying to get to a as close as possible. And whenever x is close enough, we're going to figure out what is the derivative. Okay, another way to say this is we can actually say the gap between a and x is this interval called h, so a distance, some distance h. And we're trying to shorten the distance of h so that it becomes so small that h is nearly 0. So then we can actually redefine derivative at a point in a different way. So f prime of a, which is the derivative at a, is the same idea. So we're going to take the limit as h goes to 0, meaning as you close the gap, the interval, so that it becomes 0. And we're going to say that we have this point that is a plus h. So another way to say x is just a plus h, because you're starting from a and you're moving to the right h. So x is a plus h. And we're going to subtract f of a, and we're going to divide it by the interval, which is h. Okay, so this is actually the formula you want to memorize because it is going to help you figure out the derivative at a point. And now this is the slope of the tangent line through the point a, f of a. Okay, how does that look like? The tangent line at A, remember tangent line is just a line that's actually barely touching, or it's just going through the point on the graph at that point, but it's not going through any other point. So this tangent line is going to look like that. And we're trying to figure out the slope of that line. Now, the next thing is the definition of derivative. This is very important to remember. It is trying to figure out the slope of this function at any given point. So you're actually finding the derivative of the entire function, and then you can substitute in x equals whatever number you want later, but it is the slope of the entire function. Okay, that definition is f prime of x, or derivative of x, dy over dx. dy over dx means derivative, equals to the limit as h goes to 0 of f of x plus h minus f of x over h. Okay, and then you can see that this formula is almost exactly the same as the other formula with a. We just substituted a with x because we're not looking at a specific point of a. We're just looking at a very general x. Okay, this is also the formula you have to memorize. So let's take a look at an example. So let's say you have a function 2x squared minus 3. You need to find the derivative of x, and b, you want to find the derivative at the point 4. Okay, so a is that we're going to use the definition of derivative to help us figure out the answer. All right, so the definition of derivative says f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. Okay, so how do we do that? When it says f of x plus h, what you're going to do is wherever you have an x, you're going to drop in x plus h. Okay, so for example, our function is 2x squared minus 3. So wherever I see an x, I'm going to put in x plus h. Okay, so this is x plus h squared minus 3 minus the original function. The original function is 2x squared minus 3. This is all over h. And now it's a simple algebra of trying to simplify as much as possible and then take the limit. So I'm going to just do foiling really quickly. So x plus h squared is x squared plus 2xh plus h squared minus 3. And then I'm going to distribute in that negative. So minus 2x squared plus 3 all over h. And now I'm going to just distribute everything. So 2x squared plus 4xh plus 2h squared minus 3 minus 2x squared plus 3 all over h. And then we're going to combine like terms. Hopefully things cancel. So 2x squared and 2x squared cancels. 3 and 3 cancel. We end up with 4xh plus 2h squared over h. And you can see that h is existing in all three terms, so h is going to cancel. So 4x plus 2h. Now h in the denominator will always cancel. If it doesn't cancel, then you did something wrong with your algebra. Because if h doesn't cancel, then you have a problem with your denominator, because when you're trying to take the limit as h goes to 0, so h has to be 0. And if h is still existing in the denominator, then you have a really big problem, which it shouldn't happen. So just remember, h will always cancel out of your denominator. Okay, now what you're going to do is you're trying to figure out what is the limit as h goes to 0. So you're just going to make h 0. So 4x plus 2 times 0 is 4x. So your derivative is 4x. This means the derivative of x at any given point is 4x. Okay, now we're going to look at b. Find the derivative at 4. Okay, there are two ways to do this. The first one is the long way. So we're going to take the formula that I want you to memorize, which is limit as h goes to 0 of f of a plus h minus f of a over h. And then wherever you see an a, you're going to use 4 because that's the point that you want to find the derivative. So we're now going to do the same thing that we did for f of x, or f prime of x. All right, so we're looking for the limit as h goes to 0 and f of 4 plus h minus f of 4 over h. So you're going to do the same thing now. Wherever you see x, you're going to put in 4 plus h. So this is going to be 2 times 4 plus h squared minus 3. And then f of 4 means wherever you see an x, you're going to put in 4. So minus 2 times 4 squared minus 3, all over h. And I will just do this really quickly. I'll tell you that basically things are going to cancel out, and then you get to the point where you get 16h plus 2h squared over h. Okay, h again is going to cancel, so you have 16 plus 2h. Now h has to go to 0, so then you end up with 16. Okay, now method 2. Method 2 is really if you did method 1 first. So if you did method 1 and you got the derivative to be 4x, so that means f prime of x is equal to 4x. Now if f prime of x is equal to 4x, then f prime of 4 is just substituting in 4 into x, so the answer is 16. So if you did the work for f prime of x, which is the derivative of x, then don't do it again for the definition of derivative for 4 because you're just doing double the work. Now I want you to pause the video and try number 1 yourself. And when you're done, you can come back and I will show you the solution. Okay, here is the solution to number 1. So if you got the same answer, then you can just go on to the next one. If you didn't get the same answer, you can pause the video and then look at how I solved the problem. Let's go on to the second question. This one is the same idea, so you can give this a try. The only thing that you want to be careful about is because x is in the denominator, when you're adding or simplifying the fraction, you're going to have a complex fraction, and you need to make sure that you're not making simple algebra mistakes so that you get it wrong. So again, you're going to pause the video, and then once you're done, you can come back and check my solution. Okay, here is the solution to number 2. So if you didn't get exactly the right answer, go ahead and take a second to pause the video and check the answers. If you got both of them right, you can try the third one. The third one is really hard. So I'm going to give you a few minutes to get started. What's going to happen if you got stuck is you need to multiply by conjugate. So I am going to skip the video ahead and then go to the part that you need to find a conjugate. Okay, so maybe you got to this point and then you don't know what to do. What you're going to do is multiply by the conjugate on the top and bottom. So remember, conjugate means that it's the same binomial except the sign in the middle becomes the opposite so that we can force it to cancel. Okay, so this one is going to be a plus in between. And make sure you do it on the top and bottom. Okay, and what's going to happen is you're going to have a minus b times a plus b, so then you have a squared minus b squared. So the first term is that square root t plus h plus 1. You're going to square that. Squaring that gets you t plus h plus 1. And when you, and then subtract. And then you have a square root t plus 1 squared, which is going to be t plus 1. Okay, everything is over h and times this really long thing, but it's going to cancel out, so it's not too bad. Okay, so again, I will skip ahead so you can pause the video, finish this problem, and then come back and check the solution. Okay, so here are the answers to the derivative of s and derivative of s at 1. So check your answers, pause if you want to see how the process is done if you got it wrong. The last thing in this video is just to see if you can find the derivative of the function at with a graph and at a certain point. So in these three examples, we're looking for the graph at, or derivative of the graph at x equals 0. Remember, derivative means the slope of the tangent line to the point. Okay, so let's take a look at this first one. So the first one, we're looking for the derivative at x equals 0. So you can see that x equals 0 is actually this really sharp point. And so the question is, can I draw a tangent line through that point? Well, you cannot. If the curve is not curvy, like it's not curvy in some way, then there is no derivative, because if you think about it, you cannot draw a tangent line. The tangent line has to kind of, go in a certain direction, but this tangent line will just kind of, it can go in any direction it wants, so there is no derivative. The second one is this one, the derivative at x equals 0. So if you have to draw a tangent line at x equals 0, it will have to be a straight up and line down. And straight up and line down, the slope is going to be undefined. So this one also does not have a derivative. The third one is this one. At x equal to 0, you can see that it's disconnected. When something is disconnected or discontinuous, there is no slope. So this one is also undefined.